When you're putting water valves on coils, you're going to have to pay attention to CV. If it's a 2-position valve, you can go line size and you're probably going to get away with it. If it's modulating, then you're trying to match the PSI drop through that coil. So that's where you got to figure out what CV you need in order to match that pressure drop. If you're doing a new install, the engineer's going to have a valve schedule. They're going to tell you your CV. If you're doing a one-off coil, you're going to get help from the valve manufacturer. They're going to use their calculator to figure this out. This information here is just a background of how they may have gotten there. So the formula to use would be CV equals, so CV, again, that's just, all that is how much water can I move across that valve with a 1 PSI drop. Q is what is the actual flow, so quantity in gallons per minute, times the square root of G. So the square root of G, G is specific gravity. So in the case of water, you could get rid of this because the square root of 1 is 1, and then anything times 1 obviously is the same. And then you divide that by the square root of your differential pressure you're trying to match. So let's say you're looked at a print, and that print tells you that you need 44 gallons per minute, but you don't know what the pressure drop is across your coil. So if we figure a 3 to 5 psi drop in the coil, then we want our valve to match that. Let's just shoot for the middle. We'll say our psi drop that we're shooting for is 4. So you end up with 44 divided by the square root of 4 psi, because we didn't really need this part over here. It's just there to show you. If you had propylene glycol or something like that, then you need to pay attention to that specific gravity. So 44 divided by 2 is 22. But let's say you looked at the print and the print told you that, well, you actually have 8.5 feet in WG is what the coil pressure drop is. Well, you got to convert that first. So you take 8.5 times 0.433 psi per foot, because each foot of water weighs 0.433 psi vertically. So our actual pressure drop is 3.6805 is what the coil actually is. So if we put that into that same formula as above, we end up with a CV rating of 22.935. Well, 22 and 22.935 are close enough. Unless you're getting a custom valve made, you're not going to land right on it most likely. So for example, let's say you have a choice of an 1.5-inch valve that has a 28 CV, or you can get an 1.25-inch valve that has 20 CV. Well, now you got to figure out which one should I use. Well, then you use this formula. So your differential pressure equals, so Q, gallons per minute, times the square root of G. So G is specific gravity again, divided by CV. Well, our CV is given to us up here, so we just plug this into the formula, and we go down and we start filling this out. So you'll end up with, in the case of the 1.5-inch valve, you're going to end up with 44 gallons per minute divided by 28 CV squared. So that ends up being 1.57 squared. So 2.47 is our actual differential pressure for the 1.5-inch valve. So that falls outside of our 3 to 5 psi range. So let's try the 20 CV. We'll end up with 44 divided by 20, which ends up being 2.2 squared. So our 1.25-inch valve actually ends up falling within our range. So 4.84 falls within our 3 to 5 psi drop. So I would pick this valve because I didn't go down some crazy pipe sizes. I didn't go down more than 2 pipe sizes. So I'm just going to go with this valve. Now, if you didn't fall within that range and you had two different, you were a high or low CV, then you got to pay attention to, is your pump size big enough to deal with a low CV? So the extra pressure loss you're going to get through this low CV valve. Or is there going to be a problem with hunting on the coil because your CV is high, so you're not going to have very good control of your water flow? Those are just things you got to keep in mind. If you start doing more than 2 pipe sizes, then you might come across, you'll have to probably correct the CV, and again, that's going to rely on the manufacturer. They're going to be able to tell you that they'll either have calculations or they'll help you size it. These are the formulas behind that. These are identical formulas. It's just set up different. But if I went down more than 2 pipe sizes, then it derates your CV of your valve. So because of the flow issues with the reducers. So in this case, you might have to take a valve that's rated at 20 CV and it might be derated to 0.9, so 90% of it. So then you might end up having to use a different valve. We'll go over this in another video, but I just wanted you to be aware that you might hear about corrected CV. The other thing you might hear about is choke flow. On a standard coil with 3 to 5 psi drop, I'm not worried about it because it's more in the case of steam. We'll go over this in another video again, but with water, if you drop pressure too much, choke flow just means any more differential pressure across that valve isn't going to cause any more flow through the valve because they reached that choke point. With water, what you got to worry about is you don't want that water to flash to steam because then you have cavitation, it ruins valves, all that stuff. I'm not worried about it on a standard 3 to 5 psi drop though.